Once again, you're welcome to our online lesson, and this is the question I left with you in our previous lesson for you to try your hands on. I actually went through question 1, 2, and 3 with you, and I left 4, 5, 6 up to 12 for you to try your hands on. We have to find limit of x minus 1 all divided by square root of s squared plus 3 all minus 2 as x approaches 1. Now you understand that immediately you substitute 1 into the function, you're going to end up having 1 minus 1, which is going to give you 0, and then 1 squared plus 3, which will give us 4. Square root of 4 is 2 minus 2, so you end up also getting 0. So at the end of the day, you are going to get limit of 0 over 0 as x approaches 1. And for this, we say it is undefined. And since it is undefined by directly substituting 1, then it means we have to find another way of getting the right answer. And in doing so, since the question involves a surd, we will say that then you have to rationalize. So we are going to rationalize the denominator, and therefore we're going to have it as limit of x minus 1 all multiplying the conjugate of the denominator, and the conjugate of the denominator actually will be square root of s squared plus 3 plus 2 all divided by square root of s squared plus 3 minus 2 multiplying its conjugate, which is square root of s squared plus 3 plus 2. Are you all with me as x approaches 1? Are you all with me with what I've done here? We have it as limit. We just still maintain the numerator as x minus 1 multiplying square root of s squared plus 3 all plus 2. Then this will be divided by the expansion of this, the denominator actually gives us difference of 2 squares. So you are going to end up getting square root of s squared plus 3 all squared minus 2 all squared as x approaches 1. So going further, we can simplify the denominator. So we maintain limit as x minus 1 multiplies square root of s squared plus 3 then plus 2, and the denominator will be ended up with s squared plus 3 because the square root sign will be done away with the squared, which is here, then minus 4. Going further, as s approaches 1, going further, we'll have it as limit of x minus 1 multiplying square root of s squared plus 3 then plus 2 close bracket all divided by, when you simplify the denominator, you end up getting s squared minus 1. Now as s approaches 1, again at this point you realize that when you still try to substitute 1 into the function, you end up getting undefined solution. So what we need to, or you're going to get, yes, 0 over 0, which is undefined. So it means there's still a removable discontinuity factor from it. And if you look at the denominator, you realize that you have s squared minus 1, which you can write it in a factor form. So we need to factorize. So that is going to be left with limit of x minus 1 multiplying square root of s squared plus 3 all plus 2, then divided by, in a factor form, we have x minus 1 multiplying x plus 1 as x approaches 1. Then at this point, the x minus 1 at the denominator will go into itself 1 and also go into the s minus 1 at the numerator. Therefore, they cancel out and it will be left with limit of s squared plus 3 then plus 2 all over x plus 1 as x approaches 1. So at this point, we can go ahead and substitute our 1 in there. So we'll have it as square root of 1 squared plus 3 plus 2 all over 1 plus 1, which will be left with the numerator will have 2 plus 2 all over 2, and the final answer is 2. So it means the solution to this question, the limit of x minus 1 divided by square root of s squared plus 3 minus 2 as s approaches 1, the answer is 2.
So PDY.
Yes, please.
Sir, please, I think I had a problem with, I think, the one that had the cube.
Okay, then I'm going to look at that one as well. Okay, so let's go back to that question.
And number 6 too.
Number 6. Okay, so going back to the previous page. So this is number 5. So for number 5, you needed to factorize. So the question now is, how do we factorize easily? I believe you've done polynomial functions and division of polynomial functions. Therefore, let us factorize by dividing these two functions, the s cubed minus 27 and then s squared minus 9. Therefore, dividing it, we'll use our long division method, and s cubed minus 27 can be written as, and remember, when you are using the long division method, you always need to write down all the missing addends. So we have it at s cubed plus 0x squared plus 0x then minus 27. Now, can you help me with the missing addend for s squared minus 9? It will be s squared, then what? We want to write it in the standard form, so all the missing addends should be there. The x term is not there, so plus 0x then minus 9. Good. So now we divide. We use the leading coefficients or the leading terms to divide. So s squared will go into s cubed x times. Then x will multiply s squared, it will give us s cubed. X will multiply 0x, it will give us plus 0x squared. Then x will multiply negative 9, it will lead us with minus 9x. Then we subtract. So subtracting, s cubed minus s cubed will be 0. S squared, 0s squared minus 0s squared is 0. And then 0x minus negative 9x will be left with 9x. Then we push down the minus 27. At this point, s squared cannot go into 9x. So ideally, then we're going to have it as the s cubed minus 27 divided by s squared minus 9 is the same as x plus the remainder is 9x minus 27 all over s squared minus 9. I believe you have an idea about how to write the partial fraction for a given function, rational function. So that's what I've done here. Because remember, we learned that if I have limit of a plus b as x approaches, let's say, d, you can split it and write it as limit of a as x approaches d plus limit of b as x approaches d. So that's the concept we are applying to answer this question. So going further, we are going to have it as, we've been able to write s cubed minus 27 all over s squared minus 9 in a partial form, which is this. So our question now can be written as limit of x plus 9x minus 27 all over x squared minus 9 as x approaches 3. So this bracket is affecting everything there. Now we can split it and have it as limit of x as x approaches 3 plus limit of 9x minus 27 all over x squared minus 9 as x approaches 3. So at this point, you can go further and break down this factor here. And how do we break it down? Because we can factorize directly. You can factorize. Because if you go ahead and substitute 3 there, you're still going to end up getting 0 over 0, which is undefined. So you need to factorize and break it down. So you're going to end up getting limit of x as x approaches, 3 plus limit over here. We're going to have it as 9 out x minus 3. And then the factor down there, denominator, is x minus 3 and then x plus 3 as x approaches 3. So you keep on maintaining the limit as x as x approaches 3 plus this will be left with limit of 9, because this 3 will do away with the 3 there. X minus 3 will do away with x minus 3 at the numerator. So limit of 9 divided by x plus 3 as x approaches 3. So at this point, you can go ahead and do your substitution, and it will be limit of 3 as x approaches 3 plus limit of 9. Let me do away with the limits, because we are substituting, so the limit signs should be off. So you have it as 3 here plus over here to be 9 over 3 plus 3, and that will be giving me 3 plus 9 over 6. 3 plus, let me scroll up a little to finish it. So you end up getting 3 plus 9 over 6, and this is the same as 3 over 2. 3 plus 3 over 2, which is the same as 4 whole number 1 over 2. So that is how you could have gone ahead to solve this question. Please, are we all clear now? Are we all clear? I'm trying to, okay, let me minimize it a little.
Yes, sir.
Okay, so I've minimized it. Those of you who like to screenshot it, kindly screenshot it so that I can go back to the original position, so that you follow the presentation, how it was done. So you have to just note that this has no solution. Please, are you with me?
Sir, please. So is it an examinable question?
Yes, it is. No solution is also part of a response. Now, you bear with me that,
Okay, sir.
yes, either it was a typographical error or it's a no solution, because this is how it goes. Perhaps it might be a typographical error, which I presume. Why am I saying this? Because this question might be, it should have been limit of 2x over 2x minus x squared as x approaches 0. So that per you going ahead to factorize and obtain 2x over x out 2 minus x, then you have as x approaches 0. Are you all here? Then in this case, this x would have been done away with the x at the numerator, and it will be left with limit of 2 all on 2 minus x as x approaches 0. Then at this point, you can go ahead and substitute. So you end up getting 2 over 2 minus 0. And the final answer is 2 over 2, which is 1. So either there was a typographical error to this question, or per whatever we're doing here, then there would have been no solution to the question. Please, are we all clear? Are we all clear?
Yes, please.
Yeah. It would have been different if we were looking at as x approaches infinity. It would have been different. But for now, if the question still stands as this, then there would have been no solution to it. Or if it was a typographical error for which the question should have been 2x over 2x minus x squared, which the procedure would have been this. So it's either two things. Either there was a typographical error, and if the question was maintained as this, then there will be no solution. But if the question was truly supposed to be like this, then the answer would have been 1. And if the question was as x approaches infinity, we had a different way of going about it. Please, are you all okay? So that I'll move on to today's lesson.
Yes, sir. Thank you.
So I just made mention of as x approaches infinity. Now we are going to look at limit of a given function as the x approaches infinity. But before we go to infinity, how do we understand the concept of infinity? Now, the symbol for infinity is this. I believe each and everyone can write it down. Infinity. And what does infinity means? It means it is very large. The number is really large. That's what infinity implies. Please, can you tell me the largest number or in infinity? Can you actually tell me the largest number you know of infinity? Under the real number system, can you tell me the largest number you know of, or the last number you know of in infinity? I need response, please.
Yeah, please, I'll say it depends on the quantity or the amount of something you are measuring.
Okay,
Infinity doesn't really have.
okay. Thank you so much for your response. So ideally, it depends on the quantity, and ideally too, we don't have that large number to think of. Yes, we estimate, but you cannot actually predict the large value or the last number in the real number system. So it means that in the real number system, numbers can increase from one state to the other. And therefore, we're going to find out, as I said, infinity, the limits of functions in infinity. There are some concepts you are going to use, so I want us to go over them before I move on to that. Now, let us look at something here. I just used the number line to explain the concept to you. If we have the limit of 3 as x approaches infinity, what do you think the answer will be? Now, let me explain so that I can give me a right answer. Perfect one. So this is my number line or the Cartesian plane. Ideally, the function is 3, meaning y is equal to 3. So if y is equal to 3, it means we may have our 3 here, and y equal to 3, y equal to 3 is actually a line. So that line can be drawn here. That line can be drawn here. So this is y equal to 3. So the question now is, what is the limit of 3 as x approaches infinity? And when we talk about x approaching infinity, it means x becoming so large and large. In the first place, if x approaches 1, finding the limit of 3 as x approaches 1, if 1 is here, then it means that the answer is still going to be 3. Limit of 3 as x approaches 1, the answer is still going to be 3. If we have 10 here, so limit of 3 as x approaches 10. Yes, what is the answer? When you trace it towards the line y equal to 3, what will be the answer? What will be the answer? Limit of 3 as x approaches 10. What will be the answer, please?
Three.
It's still going to be 3. So it made us conclude that limit of a constant number as x approaches a given number is still the constant number. So I believe the last time I wrote it down as limit of k as x approaches any number at all, the answer is still k. So again, coming here, as x approaches infinity, it can be 100, it can be 1000, it can be 2000, it even could be 1 million. 1 million. So the question now is, limit of 3 as x approaches 1 million. What will be the answer? So maybe 1 million is here. What will be the answer? And we are assuming the 1 million is in infinity. What will be the answer, please?
3.
It's still going to be 3. So can we conclude that limit of this constant number as s approaches infinity, the answer is still 3. Limit of 1 over x as x approaches infinity, what will be the answer? That's what we want to verify now. And it's a concept we need to know very well. It's a very strong concept we need to know very well. So that's what we're going to consider right now. So to do that, please watch this carefully. Let us have some simple investigation. I have 1 over x. And we are saying that x is approaching infinity. So x number is becoming larger and larger. X number is becoming larger and larger. So it means x value can increase from one state to the other. So I'm going to use some x value so that we can finalize it easily. So if I have x equal to 1, it implies that my function is 1 over 1, and the answer is still going to be 1. What if x increases to a number 10? It implies that I'm going to have it as 1 over 10. What is the answer for 1 over 10?
0.1.
We have 0.1. Good. Then as x increases to 100, it means our function becomes 1 over 100. What is the answer in decimals?
0.01.
0.01. Very good. Then we may have x equal to 1000. Then it means our function is going to be 1 over 1000. And I believe you tell me it is 0.001. So it means I can increase x to 1 million. Let me go straight to 1 million. And therefore, our function is going to be 1 over 1 million. And 1 over 1 million, yes, in decimals. What is the answer?
0.000001.
Okay, so ideally, watch. As x is approaching a larger value, meaning infinity, What then is the function 1 over x approaching? Now, from the beginning, when x was 1, the answer was 1. When x was 10, the function 1 over 10 became 0.1. When x increased to 100, the function 1 over 100 went all the way to be 0.01. Now we increase the s value to 1000. The function 1 over 1000 became 0.01. The function 1 over x, when x increased to 1 million, it became this. So ideally, when you approximate all of them, when you approximate this, now this is actually going to be 1. You can approximate again. This is going to be 0.1. No much approximation can be made. But from this end to that end to that end, what is happening to the s 1 over s function? What is the value approaching? To the nearest whole number, what would this be? Yes, it's approaching what? To the nearest whole number. It's approaching 0. So this approaching 0, or this approximated to, sorry, hold on. This is approximate to 0. This is equally approximated to 0. Likewise, this is also approximated to what? 0. This is equally approximated to what? 0. So it means that when you have x approaching infinity for the function 1 over x, it will also be approaching what? What will it be approaching, please?
0.
0. So it is a concept we are going to use in our discussion for limits of function infinity. It's a concept you are going to use. It's a concept you are going to use. Now, again, in as much as under limits of function at infinity, when you have any rational function of this kind, for which it is not, or it is indeterminate or does not exist, when you find limit of p of x as s approaches infinity, and then limit of q of x as s approaching infinity separately, now it means you are going to have infinity over infinity, and for such a function it is not defined. But if it is not defined, then it means we need to use the concept of the 1 over x to work it out. So that is what we are going to apply. So I want you to be very careful with our work examples. So anytime you have any rational function of this type, as s approaches infinity, you should have in mind of writing that function into the form 1 over x, into the form 1 over x. And you do so by dividing through the function by the highest power of the x present, by the highest power of the x present. So this is what we are going to consider today, the 1 over x function as s approaches infinity. You should know that it always approaches 0. Limit of 1 over x as x becomes so large, the whole function approaches 0. This is a concept you are going to use in solving questions involving functions in infinity, limit of functions at infinity. Please, are you all ready for that, so that you can start with some work examples? Are you all ready for that?
Yes, please.
Good. So to begin with, I have 4 questions here I want us to try our hands on. Question 1, 2, 3, and 4. So we have a question as limit of 2x plus 3 all over x as x approaches infinity. Remember that we don't know the large value, which is infinity, or the last highest value, infinity. So you may not know which number you are going to substitute there. And therefore, such a question, then you have to bear in mind that we actually need to use the 1 over x concept. The 1 over x concept. Now, even if you knew the large value as infinity and you place infinity here, as 2 times infinity, it gives you the infinity to a very higher power. Still is going to be infinity plus 3. The answer is still going to be infinity because you don't know what is there. Divided by infinity. So at the end of the day, if you substitute infinity in here, you end up getting infinity over infinity. And therefore, this becomes undefined at that moment or undetermined at that moment. So in this case, to work out the solution for this, we must use the 1 over x concept, which is found in infinity. And to do so, we said that you look at the highest power of the variable x under discussion and divide each term by that. So we are going to have it as limit of 2x. The highest power is actually x. So divide that by x plus 3 over x all over x over x as x approaches infinity. Please, have you understood the division that I've made here?
Yes, please.
So going further, we'll have it as limit of 2, because this x will do away with the x here, plus 3 over x, all divided by 1 as x approaches infinity. Are you all with me? So at this point, this 3 over x is the same as 3 times 1 over x. 3 times 1 over x. And with the theorems of limit, we learned that if you have limit of a given function in a rational form, you can split it up. You can split it up. So you're going to have it as ideally limit of 2 as x approaches infinity plus limit of 3 1 over x here as x approaches infinity, all divided by limit of 1 as x approaches infinity. So going further from here, limit of 2 as x approaches infinity. Please, what's the answer?
2.
It's 2. Then plus limit of 3 times 1 over x. Over here, 1 over x ideally becomes as x approaches infinity. Okay, what's the answer for this one? It becomes what?
0.
It becomes 0. Very good. All over limit of 1 as x approaches infinity. What's the answer?
1.
It's 1. So finally, we are going to have our answer as 2. We'll have our answer as 2. So limit of 2x plus 3 over x as x approaches infinity. The answer is 2. The answer is 2. Please, are we all clear with what I've done here?
Yes, please.
Okay, so let us try. You'll be doing question 2 for me. So let us try with question number 3. Let me go straight to question number 3 so that you do question 2 and question 4 for me. So let me go to question 2. Sorry, question 3. So copying question 3 to another page. I may have it here. Again, thinking of it, if we substitute infinity here, you are going to have infinity minus 5, and the answer is still going to be infinity because you don't know the largest value actually being substituted. Over here is going to be infinity squared, which is still infinity, plus 5 times infinity, it is still infinity, minus 4. So it is infinity, because whatever happens, you are going to get infinity over infinity, which is undetermined as at now. Then again, looking at this, if you even try to factorize, is it easy for you to factorize this? And when you finish factorizing and you cancel out, it means whatever you're going to substitute is still infinity. So you're going to end up getting infinity over infinity. So in a way of solving this question in infinity, then you must apply the 1 over x concept, whereby the 1 over s concept in infinity is 0. So you end up substituting and then you end up breaking and getting your solution. So we say that in order to get a 1 over s concept in the question, then you must bring on board dividing the function given to you with the highest power of the variable x under discussion. So if you look at this question, what is the highest power of the variable x?
X squared.
It's s squared. Okay, so I'm hearing 2, I'm hearing s squared. The actual answer must be the highest power is 2, but the term there is s squared. So we are going to divide through by s squared. And that therefore we're going to have it as x divided by s squared minus 5 divided by s squared. Let me write it well. Hold on. So this is going to be limit of x divided by s squared minus 5 over s squared, all divided by s squared over s squared minus 5x over s squared minus 4 over s squared as x approaches infinity. Going further, breaking this first term up, we end up getting 1 over x minus 5 over x squared, all divided by, this will end up giving us 1 minus 5 over x squared, 5 over x, 5 over x, then minus 4 over x squared as x approaches infinity. So this is where we got into. So at this point, the limit of function will be affecting them separately. Yes, I don't want to write so much. The limit of function will be affecting them separately. So this is going to give us, okay, let me write it. I have some space there. This is going to give us limit of 1 over x as x approaches infinity minus limit of 5 over s squared as s approaches infinity, all over limit of 1 as x approaches infinity minus limit of 5 over x as x approaches infinity minus limit of 4 over s squared as x approaches infinity. So per the 1 over s concept of function as s approaches infinity, what are we going to obtain? What is the answer here?
0.
0. Minus, what's the answer here?
0.
It's still 0. Good. All over, what do we have here?
1.
1. Good. What do we have here?
0.
0. And then minus, what do we have here?
0.
0. So you end up getting 0 over 1 and the final answer is 0. Unlike when it was infinity over infinity, which is undetermined. But when we use the 1 over s concept, then we ended up getting the answer as 0. Please, are you all with me?
Yes, please.
Good. So I would like you to try question number 2 and question number 4 for me. Work out question 2 and question 4 for me. Question 2 and question number 4. I'm giving you approximately 3 minutes to finish it up.
Please, the second one, I had negative 2 over 7.
Okay, so you had negative 2 on 7. How about the fourth one?
So that one, I want to ask the question first. When you're dividing through by the term with the highest power,
Yes.
is it
From the denominator or the whole thing?
It's the whole thing. So you look out for the highest power in the function and divide through by that.
But I want to make it undefined.
No, it wouldn't. It wouldn't. Limit, the highest power of x is actually x to the power 1. So we have it as 3x divided by x and then plus 2 over x. 2 over x. And then all divided by 9x over x minus 7 over x. So as x approaches what? Infinity. This will be leading us to limit of 3 plus 2 over x. That will be left with all over 9 minus 7 on x as x approaches infinity. Now bear in mind that you're going to expand the limits as x approaches infinity through the brackets. So it will be limit of 3, and limit of 3 as x approaches infinity is still 3. Limit of 2 over x as x approaches infinity will give us 0. And limit of 9 as x approaches infinity will be giving us an answer of what? An answer of what?
9.
9. Then limit of negative 7 on x as x approaches infinity. The answer is what?
0.
0. So finally you end up getting 3 over 9, and the final answer is 1 on 3. So this is how you go about solving question number 2. How many of you had it right? Because I remember you shared with me negative 2 on 7. So I'm wondering how you had a negative 2 on 7.
So I actually had the 1 out of 3, but I mentioned the answer from some other different question.
Oh, okay. Okay. So the answer is actually this. Now coming to question number 4. Question number 4. Question number 4, we may have it here. So we ask, once again, you divide through by the highest power, which we've seen it as x squared. So dividing through by the highest power, we have limit of x squared divided by s squared, then plus 2x divided by s squared minus 3 divided by s squared, all divided by s squared, all divided by x over x squared, then plus 7 over x squared. Are you with me?
Yes, please.
Okay, so going further, as x approaches what? Infinity. Going further, you end up getting 1. So limit as x approaches infinity for 1 plus 2 on x minus 3 on x squared all over x, that is 1 on x plus 7 on x squared. And therefore, at this point, then the limits need to affect them separately. So limit of this will give us 1. Limit of 1 as x approaches infinity is 1. Limit of 2 on x as x approaches infinity is what? 0, right?
Yes.
And then limit minus that is also going to give us 0.
Mhm.
And then limit of 1 over that will give us what? 0, right?
0.
Then plus another 0. So finally, you are getting 1 over 0, which is, as you said, undefined. So whatever the case may be, per this question, the solution is undefined. Please, am I clear?
So, please, I have a question to ask.
Yes, I'm listening.
So, does it mean that you can have this as an answer?
Yes, you can have it as an answer. Yes, you can have it as an answer.
Okay.
All right. So
Thank you.
I have this set of questions here. I would like you to go through. I'm privileged to have you coming online for this discussion. And thanks so much also for subscribing to the YouTube channel. And I believe those of you who went there to look at some of the questions, or the tutorials there, you were okay with it. You can leave your comments if you have some challenges with some of the concepts you are not getting clear, and I'll definitely respond to such questions. Or you can inbox me directly and I'll also respond to that. So these are some few questions under limits of functions in infinity, and I'd like you to try your hands on it and give me a feedback. I'll be expecting it. This actually ends the lesson on limits of functions, and in our next lesson, we'll be moving on to something different. Thank you so much and have a nice day. Bye-bye.